Question 10. The members of a club voted for a new president. There were 15 candidates for the position of president and 3,543 members voted. Each member voted for one candidate only. One candidate received more votes than anyone else and so became the new president. What is the smallest number of votes the new president could have received? The solution to this problem is based on the pigeonhole principle. Now, each candidate on average received 3,543 divided by 15 votes, which equals 236.2 votes per candidate. But the number of votes cast is an integer, not a decimal. And one candidate was the winner and got voted president, which means that that candidate would have received more than 236 votes. So I would like to find out how many more votes that candidate would have received, at least as a minimum, to have been voted the president. Now, something else to be mindful of as well, that one candidate received the most votes, not at least one, which means there is a clear winner. Now, 3,543 minus 15 multiplied by 236 votes means that there were 3 votes remaining that need to be allocated to some candidates. So if we just assume that each candidate received 236 votes, not 0.2, but just 236 as an integer, multiply that by 15, subtract that from 3,543, which means that there's 3 votes floating around that need to be allocated somewhere. Now, by the pigeonhole principle, one candidate would get 2 out of those 3 extra votes, or those 3 votes remaining. So if we take 236 as the integer and then add the 2 extra votes that that candidate would have received, the minimum that candidate would have received to be the winner would equal 238. So therefore, the answer is option C.